This is R.D. Sharma solution, class 12, chapter 18. Maxima and Minima, exercises 18.5. Prove that the least perimeter of an isosceles triangle in which a circle of radius r can be inscribed is 6 under root 3r. Now this is a triangle we are talking about. This is isosceles. Isosceles means the opposite side or two sides should be equal. Now if you take this ABC, these two sides are equal. So you have to mark it by yourself. That is, in triangle ABC, AB is equal to AC. This is the first thing. Now the second thing comes is because this is x and this is y, because both sides are equal, two sides are equal. That's why we have taken as x. Now inside we have a circle and there are certain properties you must know. So when you join this is a median, because in center is there is a median, and since it is an isosceles triangle, that's why it is a median. Otherwise it would not have been. And the properties of isosceles triangle and the median, when you see that if we take these points D, E, F, which touches the inside of the triangle, so we have this second thing which comes, O is the center or the center of the circle, then this divides the median, the center of the circle or the point where the center of the circle is, a line joining the end of or a vertex of a triangle or isosceles triangle to the opposite side passing through that center will divide this line into 2:1. So if AO is 2R, OF is going to be R. That is 2:R. Relationship will be twice of R. Now let us take this one and this one. So I am taking this triangle, and since we are applying the Pythagoras theorem here, and since the both sides are isosceles, means the sides are equal, this will be 90 degree. Please remember, if it would not have been isosceles triangle, we wouldn't have got all these properties. This is just because this is an isosceles triangle. So the 2:1 and the perpendicular from A to BC or CB, this all comes like this. So I'm talking about this A, this is F, which is perpendicular, passing through the center also. B is here. So I'm taking AFB triangle. Now in this triangle, you can take the Pythagoras theorem. AB is x, FB is y by 2, and AF is AO plus OF. AO is R, actually it's 2R, and OF from the center to the side of BCF, OF is R. So you have 2R and R. This is y by 2, this is y by 2. As I said, this is the property. If you have isosceles triangle, this goes y by 2, half of it. Now we have x square equals to AO plus OF whole square plus y by 2 whole square. Again, this is y by 2, this is x, and from here to here, this, assume that there is a point O here. So OA will be 2R, OF will be R. So AO, as I said, it's 2R, OF is R. So it's combined weight is 3R. 3R whole square is 9R square. So let me write it as 3R square or 9R square you can write. And here you have y by 2 whole square. So y square by 4 you can assume. Okay. Now this is the first equation you have. Now next one is, which is the fourth step you can say, because we have got a relationship between x and y which we have imagined. Now you just join these. What do you get? ADO. See, this AO is 2R, AD is x by 2. Similar logic as this FB was y by 2. Similarly, AD will be x by 2 because it is perpendicular. Again, the center of the circle, we have dropped a line which is perpendicular to this. Or even if you imagine the other aspect, one is R, one is 2R, this one, and this is x by 2. This is D. So AD square equals to, you can take the triangle ADO, 2R whole square, which is the hypotenuse in this case, is equal to R square plus, what is this side AD? You can just write it as AD. Now tell me whether it will be x by 2 or not. I told you that it may be x by 2, but you have to tell me about that. So this AD square is 4R square minus R square, that is 3R square. So AD will be equal to under root 3R square, that is under root 3 into R. This is your AD. Okay. Now the next thing comes, there comes the property of the tangent. That is, you have this A, B, C, and this is the circle inside. This is your D, this is E, this is, and please remember, this is not an isosceles or triangle related or circle related question. This is basically a trigonometry and shape mensuration related problem, because there are so many things involved here. When we drop a perpendicular from one point to the two sides of a circle, or there is no side of the circle, but to end of the circle, they become equal. So CD equals to CF. From A if you drop, it's AD equal to AE. From B if you drop, it is BE equals to BF. So as I said, y by 2 can be there, but what do you think that it will be x by 2 or not? You have to tell me. Now what was AD? I just told you it was under root 3r. We just computed it. And this AD plus DC is what? Please remember, because the side equal are AC and AB. What do you think? Whether AD and DC will be x by 2. First thing is AD will be equal to root 3r. DC is what? DC, this one, DC and CF are equal. See, AD or DC will not be equal to x by 2. You know why? Because the sides which are equal are AC and AB. So x is equal to root 3r plus y by 2. Okay? From here we'll get a relationship y by 2 equals to x minus under root 3r. This is 2. What was 1? Just let me know what was 1. You have to replace that one thing in here. Or you can use this first expression and second expression. Because of the lack of the space, I actually erased everything. So this is 3r square plus y by 2 whole square equals to x square. This we already know. This we have already computed. Now this y by 2 equals to x minus root 3r. This 3r square, y by 2 is already there. So in place of y by 2, we can replace it by x minus under root 3r. This is whole square equals x square. Now open this. This is 9r square plus x square plus this is 3r square minus 2rx under root 3 equals to x square. X square you can cancel and there will be a relationship between r and x. So just by rearrangement, you will get certain relationship. And that relationship or that expression from on left and right, that is x equals to 6r by root 3. This side actually AC, or you can call it as AB also, because they both are equal. And from second equation, y by 2 is equal to 6r by root 3. And I'm writing this x as 6r by root 3 minus root 3r was already there. So y you got as 2 root 3 into r. Now x and y is already there. The thing which they are asking is perimeter. Double differentiation, because we haven't done single differentiation. How to do the double differentiation? That question comes in this question. But just for the sake of completion, we have to do this question. So P is equal to x plus y. So it's 2x plus y. So 2x is 6r by root 3. Y is 2 root 3r. So perimeter is going to be 12r by root 3 plus 2 root 3 by r, and when you combine them, you will get 6 root 3r. So perimeter is equals to 6 root 3r. Now the problem in this question which I faced, and you will also face if you are doing it by yourself, where we are going to do the differentiation. We haven't differentiated at all. If we haven't differentiated, we cannot go for the double differentiation. So double differentiation is mandatory for least and maximum. Next question is, find the dimension of the rectangle of perimeter 36 cm which will sweep out a volume as large as possible when revolved around one of its sides. Now this is your rectangle, and this is L, this is B. You can assume any variable. So length and breadth you have found out. Now you take one of the side and just revolve it. Once you revolve it, what are you going to get? You will get a right circular cylinder. This is your length. What I am trying to suggest here is, length and breadth are the dimension of the rectangle that we have assumed, and V is the volume we are assuming. And since this rectangle is from one side, the radius of the right circular cylinder will not be L by 2 actually. We are not taking a center line from the passing through the center of the rectangle and then revolving it. We are revolving it around one line which is B here, which is the breadth. So this is length, length and breadth. So the perimeter is 36, so 2L plus 2B is 36. L plus B is 36 by 2. 36 by 2 is 18. So we get a relationship between length and breadth. So you can have B equals to 18 minus L, or L equals to 18 minus B, whichever way you want, because we are going to differentiate it anyways. Volume is what? Pi r square h is the volume of the right circular cylinder. This is your L. So this is pi r square h, 18 minus b whole square into h. H is what? B. when we differentiate it, dv by db we have to do, and you can do it by multiplying b inside, or 18 minus b whole square. You can open it. So when you open this and multiply it inside, so you will get certain differentiation here. So I am just saying that 18 minus b whole square has to be opened, multiplied by b, and just differentiate it. So when you multiply this 18 minus b whole square into b, you will get this expression. But dv by db, when we differentiate it with respect to b, what are you going to get? This expression. Next one is, of course, dv by db has to be equal to 0. So 324 plus 3b square minus 72b equals to 0. You can take 3 common from here. When you take 3 common, you are going to get b square minus 24b plus 108 equals to 0. And you will get 2 factors here, because 24 is 6 and 18. Because 6 into 18 is 108. So you will get b minus 6 minus 18, b minus 6 equals to 0. So b minus 18 into b minus 6 equals to 0. So b will be either 6 or 18. But we need to check for both of these, because we need as large as possible. For that we need double differentiation. So the fourth thing we have to do here is d2v by db square. You already know dv by db. Now you are going to differentiate it. When you differentiate it, you will get an expression, and in that expression you have to first put or replace b by 6. The other time you have to replace b by 18. After replacing 6 and 18, you will see whether it is going to give you a negative value or a positive value. Because as large as means you need to get a negative value. That is important here, negative value. So 324 minus 3b square minus 72b. When we differentiate this, and differentiation, double differentiation, I am doing the double differentiation. 6b minus 72 will be the result, and pi will also be there. Pi into 6b minus 72. So when b is equal to 6 is 36 minus 72, so you will get minus 36 pi. And since it is negative, what are you going to get? B equals to 18, because once you got negative, it's maximum. When you put b equals to 18, you are going to get 36 pi. So it's positive, so you will get minimum. We have to take only the value for which you are going to get the maximum thing, or volume maximum. So I am taking b equals to 6. So L will be what? 18 minus 6, that is going to be 12. So length is 12 and breadth is 6. So length and breadth are these values, and which is the answer, because the dimension is being sought after in this question. So the diagram you need to make, because most of the time people will think, or students will think, that normally we revolve it around the center line, but here it is not. You are revolving it around the breadth b, which we assume, or the height actually. You can call it as a height in this case. All other things remains the same, making expression, equating it to 0, all this. Show that the height of the cone of the maximum volume that can be ascribed in a sphere of radius 12 cm is 16 cm. Now this question we have already done. The values were not there, but this kind of question we have already done. So we'll directly deal with the expression we got. Let me just remind you, or make you recall, that in a sphere, 3D sphere, there is a cone inside. So h and r and v, height, the radius and volume we have taken. These are the anticipated or guessed value, let value. H and R are these. Next one will be the volume. How about the volume? How are you going to compute the volume? First of all, if you see the center, I am joining with the circumference radius, capital R. So capital R is the radius of the sphere that we have assumed now. The first thing which we have written are the imagined variables of the cone. Okay. How about this height? See, let me just write it here. H equals to, from here to here it's capital R, from here to here it will be capital R square minus R square, because we are using the Pythagoras theorem. This whole height I am talking about, R plus under root R square minus R square. So this question already done, that's why I am just doing it quickly. So H equals to R plus under root R square minus R square. All the small and capital R are going on. So H minus R will be equal to under root R square minus R square. You can just square both sides. So you will get h square plus r square minus 2hr. Here you will get r square minus r square. You can cancel this capital R square here. So there will be a relationship between h small r and capital R. So R square will be equal to 2HR or 2RH minus h square. The third is volume is 1 by 3 pi R square h. 1 by 3 pi R square, we will replace it by 2h capital R minus h square. R square we can directly replace it here. You can also mark this as the equation 1, and you can just say in English that we are replacing equation 1 in equation 2. Equation 2 can be v equals to 1 by 3 pi R square. That is the way you need to put in ink paper. Now second thing will be, or fourth thing will be actually dv by dr. We are differentiating it now and we have to put it as 0 also. So I am differentiating this expression now. Once I have differentiated it, pi by 3 and bracket 4hr minus 3h square, dv by dr equals to 0. When you place dv by dr equals to 0, again h equals to 4r by 3, that you already know. We have proved it as twice of r, that is 2/3 of diameter in previous question. Next thing will be d2v by dr square. So we differentiate it now and we double differentiate it now. Second differentiation, when we double differentiate, you are going to get this expression 4r minus 3 to the 6h. So 4 minus 6h. Now you have to place h equals to 4 capital R by 3. And you need to find out whether you are going to get negative value or positive value. If you get negative, it's maximum. If you get positive, it's a minimum. So this is d2v by dr square, and already the values are given because radius is 12 centimeter is known to us, 16 centimeter we have to compute. So now I am replacing this h by 4r by 3. You can just take this 4 outside because we are more interested in the sign here. It's minus 3r by 3. You can just cancel this. It's minus 4 pi r by 3. So what do you get? It's negative, it's less than 0. So you are going to get the maximum value. And maximum volume is when h is equal to 4 capital R by 3. Now in the question, capital R is already given, which is 12 in this case. So h will be equal to 4 into 12 by 3. It's 16 centimeter, which is asked in the question also. So we have computed the height, which is 16 centimeter, for the radius of sphere, which is already 12 centimeter. So all this procedure is known to you, and we have actually recalled that question we have earlier completed with the actual numbers 12 and 16 here. So all this let, imagined value, and finally h equals to 4 r by 3, will replace r by 12 in order to get 16, which is the height. A closed cylinder has a volume of this one 2156 centimeter cube. What will be the radius of its base so that its total surface area is minimum? So you can make a closed cylinder. Closed cylinder means the lid are closed. Volume is equal to pi r square h. This is small r, this is h. And better is to always draw the diagram that gives, you see, one picture is equivalent to 1000 words. So r and h we have imagined. What will be the radius of the base? So r we need to find out. The volume of the question in the question is already given. So it's 2156. You can directly replace or equate this pi r square h with 2156. When you get h, it will be 2156 by pi r square. And let me tell you, you can just use pi equals to 22 by 7 in this question. We have to use this pi as 22 by 7. We cannot just write just pi. So when you just have this h equals to, I've replaced pi by 22 by 7, and this is what we got. What is the total surface area? Total surface area of any shape is the curved surface area plus the area of the base and the top. So pi r square h is there, and 2 pi r square above, pi r square in the of the base. So pi r square h plus 2 pi r square, this is the surface area. So 2 pi r, you can just write h as 686 by r square, and 2 pi r square is already there. And since we need the radius, we have to differentiate this s with respect to radius. After simplifying this expression, 4312 by r, and this again, as I said, pi has to be written as 22 by 7. So better way is always in this question particularly, most of the question we have not used pi, we have just kept pi as pi only. Here you have to actually take pi as 22 by 7, and you get this expression pi equals to s equals to 4312 by r plus 44 by 7. This is 44 by 7 r square. Now next thing is ds by dr. Differentiation we have to do. because minimum maximum can only be done like that. So it will be minus 4312 by r square. 1 by r differentiation is negative 1 by r square. And this r square will be 2r. So it will be twice of r into 44 by 7. Next thing is ds by dr equals to 0. You have to differentiate and then equate it to 0. Once you equate it to 0, so finally r what will come, because the question is quite clear and very evident, r will come as 7 cm. Now since this r is 7 cm, you have to do d2v by dr, d2s by dr. Double differentiation we have to do in order to find out negative and positive. Because if the surface area has to be minimum, you have to get a value which is positive. We need positive value. So we will get this one, 176 divided by 7. It is greater than 0, so we are getting the minimum value. Apart from this, there is not much use of d2s by dr square. So radius is 7 cm. That is the answer of this question. Radius is 7 cm. This is the procedure. So whatever we have discussed, this is here only. You can follow this and use it. Making a diagram is always beneficial. This question we will take in the next discussion. Thank you so much.